Let us look at proposition number 4 of Works of Archimedes, specifically from book 2 of On the Sphere and Cylinder. The proposition says to cut a given sphere by a plane so that the volumes of the segments are to one another in a given ratio. So let's take it step by step. Given a sphere and two magnitudes R and S such that R is less than S. Take a great circle with diameter A prime and O the center. Now produce OA to D such that OA is equal to AD. Divide AD at E such that AE is to ED is equal to R is to S. Let M be a point on AA prime such that MD is to DE is equal to AA prime square is to A prime M square. We'll come back to this point, this particular step later, because there's a story behind it. Now, through M, construct a plane perpendicular to AA prime. And, although not mentioned, let's mark the intersection of this plane with the great circle BB prime. And let's join these 2 points. Now, extend A prime A to H such that OA prime plus A prime M is to A prime M is equal to HM is to MA. And now similarly extend AA prime to H prime such that OA plus AM is to AM is equal to H prime M is to MA prime. Basically, if you go back to book 2 proposition 2, you will realize that this is the condition for a cone to be equal to the segment of the sphere. So we have these 2 cones. So one of this condition is to make sure that this cone is equal to this segment of the sphere. This cone is equal to the segment of this sphere. Now, which means what? That this circle with diameter BB prime passing through M is a common base to both these 2 cones. So the bases are equal, which means that the volumes of these 2 cones are going to be proportional to their heights. That is, HM is to H prime M. And the requirement is that it should be equal to R is to S. So we have another statement. HM is to H prime M is equal to R is to S. If we are able to identify where is H, where is H prime, and where is M, because we have 3 equations with 3 unknowns. Because remember here we said let M be a point on AA prime such that this condition is satisfied. And once we have M, then we can figure out where H and H prime is. So that means we have to eliminate H and H prime to arrive at M. You know, the lot of work is there in the PDF book. Here I am just taking the key points from there. Using 2, we arrive at A prime H prime is to H prime M is equal to OA is to OA plus AM. Using 1, we arrive at A prime M is to AM is equal to OA prime is to AH. All the intermediate steps are there in the PDF book. Using 2 again, we arrive at A prime M is to AM is equal to A prime H prime is to OA. And using 5 and 6, we arrive at H prime is to H prime A prime is equal to OH prime square is to A prime H prime square. And then using 6, we arrive at H prime is to H prime A prime is equal to A prime square is to A prime M square, which is equal to MD is to DE as per our construction. A prime H prime is to H prime M is equal to OA is to OA plus AM. 4. Now, OA is what? OA is equal to AD based on our construction. So that means OA can be written as AD. Again, OA plus AM. OA plus AM. But OA is equal to AD. So AD plus AM, which is MD or DM. So this becomes AD is to DM. If you notice here, we have H prime is to H prime A prime. I have written it in this form, the ratio. And I'm multiplying it with this. A prime H prime is to H prime M. Now, think of it like this. These two ratios are equal. That means the product of the left-hand side will be equal to the product of the right-hand sides, which is what I'm doing here. Now, when we do that, what happens? A prime, H prime, A prime, H prime, they cancel out. MD and MD gets cancelled out, so that we are left with H prime is to H prime M is equal to AD is to D. We carry out dividend law. H prime minus H prime M is to H prime M is equal to AD minus D is to D. That becomes H prime minus H prime M is nothing but HM. So HM is to H prime M is equal to AD minus DE. AD minus DE is AE. So it becomes AE is to DE. Since HM is to H prime M is equal to AE is to D, and AE is to DE is equal to R is to S. That means HM is to H prime M is equal to R is to S. Now, what is HM? Is the height of this cone, and H prime M is the height of this cone. So we have shown that the heights of these cones are in the same ratio as R is to S, which means that the cone B prime H, the purple cone, is to cone B prime H prime, green cone, is equal to R is to S. Why? Because as I mentioned previously, the base of these two cones is equal. That means the volume of these cones will be proportional to the heights of these cones. So that is how we can say that cone B prime H is to cone B prime H prime is equal to R is to S. But these cones, that is cone B prime H is equal to segment of the sphere, that is the solid of rotation of B prime about MH. And cone B prime H prime is equal to segment of the sphere, that is solid of rotation of B prime about MH prime. So segment of the sphere B prime is to segment of the sphere B prime is equal to R is to S. So basically, we have identified the plane which cuts this sphere into two parts in the same ratio as the given ratio in terms of volumes. Remember, I said I have something additional to talk about here. Let M be a point on A prime such that MD is to D is equal to A prime square is to A prime M square. Now here the issue is MD is to DE. MD is a length, DE is a length, but A prime square is a area. It's a square. Although it doesn't look like it because it's a three-dimensional one. The figure is slightly tilted. That's why it looks like a rectangle. But it's actually a square. And A prime M square. Okay. So what we have to do here at this point is to find a point M such that MD is to DE is equal to A prime square is to this square. Now what Archimedes did was he explained the context, but actually didn't go into explaining the various steps involved, which he promised he will do later. But then he never got around to explaining it. I'm also going to leave it as it is. But since it is actually not provided by Archimedes himself, but other authors have provided the solution for this, how to find M. So maybe later at some other point in time, I will make another video on this specific aspect. So that is proposition number 4 of works of Archimedes, specifically from book 2 of On the Sphere and Cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.